So do we have more? Well, we have already have a few minutes, I mean, more than 10, 15 minutes of discussions, but is there any more questions we have? Or should we wrap up for today and wait for an exciting day tomorrow?
This is Doug. I do have a general question. Dave, you showed the visionary atomic observatory with a space segment. And June also mentioned applications of space, including the one about clock synchronization and comparison. Looking to the future, what altitude would you like to have satellites at, and what are the physics capabilities? So I get it with gravitational waves, you'd like a very long baseline. Are there other physics or technology reasons why you'd like something higher than, say, medium Earth orbit?
So, I mean, the quick answer is, you know, in the far future, we'd like them at all altitudes. We want the network to be as big as possible, but maybe that's not getting at the actual physics that you want to look at. So, you know, one thing that will definitely be possible with a space-based optical clock is doing a more sensitive test of relativity theory. So
Right.
General and special relativity will both go into the frequency ratios that we measure between space-based clocks and Earth ones. And so in my mind, what you would like to do there to get the longest lever arm is to reduce the gravitational potential. I guess it's going up, you're increasing the gravitational potential, but you would like to do a significant fraction, you know, of the depth of Earth's gravitational potential. And I don't know exactly at what altitude that happens. It's something on the order of the radius of Earth. So, you know, 10,000 kilometers, I think, is kind of a good thing to shoot for. That happens to be what the altitude that a former space-based test of general relativity got to with hydrogen masers.
Yes.
And, you know, the precision has improved by orders of magnitude since then.
Good, thanks.
Maybe I'll also add a comment there. But you know, Dave showed the clock photo area clock network, where I thought that there's one piece of technology that we didn't quite emphasize today, but it's actually very much a key for future, is this Nate Newberry's group's technology, where you can send the laser beams in free space. And in fact, the clock comparison is done by, actually, Dave didn't mention that, having a telescope sending laser beams between the two buildings. If you can do that over kilometers horizontally, or you could do that a kilometer vertically. And perhaps what we could do is, well, let's go 100 kilometers, and you will be now in the Earth orbit. And the last, you know, the first 10 kilometers is going to be difficult because you have atmospheres. But beyond that, it's going to be easy because it's all vacuum. So that's probably the first piece of technology I think we would love to see established. You know, this is something, again, I'll share with you this little picture that at NIST we have been discussing this. If we could start to have this near Earth orbit where you can have the light going back and forth to synchronize it. And these clocks are good enough that you can fly over continent, so-called hold over time, and you can beam down the time in a different continent. Now you start to be able to compare these clocks. But ultimately, of course, where do you want to go? If this becomes a space telescope, I would love to have, I made this proposal to DARPA one time, 2 years ago. I think we would want to go to a master clock where you go to sit in this Lagrange point. Well, there's a gravitational zero, and you just have a master clock sitting there. There's no fluctuations, and you beam down with the optical links. But these are almost a science fiction, but we need the technology to eventually get us there.
Good, that's great.
Great, Marianne.
So just a comment on exactly the same question. So if there is such a field with scalar field with quadratic interactions, that it will cause actual difference in fundamental constants around Earth, you want to be at about size of the Earth diameter to maximize the effect. So about the same as Dave was mentioning for the other reasons.
Yes.
Great. Okay, so let me then thanks all the speaker of the session, and hopefully I can see all of you tomorrow at 8 a.m. Pacific time.
Thank you.
Thanks a lot.
Thanks all.
Bye.
Thanks.
Thanks
See
for
ya.
coming.
Bye-bye.
Thank you.